Hello and welcome. In this activity, I'm going to explain to you how to complete activity 2.2, and really that involves really understanding how scientists think about variability and really how statisticians think about variability. So let's get started. Really, science is about trying to partition variability. It's about how to explain variability in measurement. So let's start with an example where you are trying to study something, you're trying to measure something, hopefully something that you're interested in. And let's just say you're trying to measure something like happiness or cholesterol levels. Very different examples, I understand. And as a metaphor, I want to use a baseball or just any object. And we're going to say that the size, the circumference of this object represents someone's happiness. And so the first step we want to do is measure this thing. And so science starts with measurement. So we measure this thing and then we measure another thing. And then what we want to do is we want to compare this person is happier than this person. Well, how much happier? And what is it about this person? What characteristics does this person have that makes him or her happier than this person? Or you could do it with cholesterol. Why does this person have higher cholesterol than this person? In order to identify patterns in variability, these types of people tend to be happier, or these types of people tend to have lower cholesterol. In order to identify patterns like that, you have to be able to accurately measure something. Then after you identify these patterns in variability, you then need to try to test hypotheses to determine what it is that's causing this person to be happier than this person, or this person to have a lower cholesterol level than this person. All of that comes down to measurement, and all of that comes down to variability, because you're trying to identify the patterns and variability. What types of people have higher or lower cholesterol, have more or less happiness. Now, scientists think about variability in a very specific way. Variability is just when you get differences in scores. So if I have a bunch of numbers and they're not all the same, I have variability. Those numbers can represent differences in cholesterol, or they can represent differences in happiness, either way. But that variability in scores, regardless of what they're measuring, that variability in score is caused by three things. And those are these three things listed here: measurement error, individual differences, and treatment. The point of this video is to get you to be able to think about these terms and really identify the types of variability that would be created by measurement error, or the types of situations that create measurement error, the types of situations that create individual differences, and the types of situations that create treatment variability. So I'm going to walk through each of these terms right now, giving you an example. So measurement error defined is simply measuring something and getting a value that's not perfectly accurate. Now, the sad story is anytime you measure anything, you're probably going to have at least some measurement error. But let's go back to our metaphor about an object's circumference. And again, let's say that this is measuring the size of this ball represents someone's happiness. So we want to try and measure this thing. Now, one way I might try and measure it is to take a ruler, line it up on the seam, roll it around. If I do that, I get about 24 and a half centimeters around this thing. Now, that doesn't look too accurate, right? Well, there are other ways to measure the circumference that might be more accurate. Maybe I could take this ruler, which is flexible, and so this would be more suited to measuring the circumference of this object. And when I do that, I get 23. So this method of measurement is more accurate than this method of measurement. So this method has less measurement error, and this method has more measurement error. Now, obviously, you want to reduce measurement error. Now, how does this relate to measuring something like happiness? Well, there are different ways to measure happiness too. Like a questionnaire, you might have two questionnaires, and one questionnaire might be more valid than another, more accurate. Or you might have another way to measure happiness. Psychologists have lots of clever ways to measure things. But you have to recognize that there's different ways to measure things, and some are more accurate than others. There's always going to be some measurement error. No matter how you measure something, you can never measure it perfectly all the time. And as a scientist, you want to minimize measurement error. Now, how does that come into play? Well, you want to make sure that you are measuring something in a precise way. You want to measure it in a procedure so that if the way I measure it is similar to the way someone else does it. So you will reduce measurement error as much as possible by having standardized measurement procedures so that everybody's doing it the same way. Now let's move on to a second source of variability called individual differences variability. Now, objects differ in size. People have different amounts of happiness. This person might be happier than this person. But as I said earlier, as a scientist, I want to try and measure. I want to try and quantify how much happier is this person than this person. How do I do that? I want to measure it. I have to measure it. So I'm going to have different ways of measuring objects, and hopefully I'm going to choose the most, or measuring happiness, and I want to choose the one that is most accurate, of course. Now, when I measure these two objects, hopefully using the most accurate way of measurement, I'm going to find that they're different. This one is 23 centimeters around, and this one is 21 centimeters around. So you might be thinking, okay, so this is 2 points happier than this. However, that's probably not exactly right, because my measurement of this object's happiness had measurement error in it. So while my best guess at this object's happiness is 23, and my best guess at this one is 21, and the difference, my best guess, would be 2, I have to recognize that that 23 probably is contaminated. It probably has some measurement error in it. And this 21 probably has some measurement error in it. So we just have to recognize that anytime we measure something, we're always going to have some measurement error. So that makes it difficult as a scientist to talk about how much happier this object is than this object, because, or this person, this participant, because you know that you have evidence to suggest that they're differ in their happiness, but you can't say precisely how much more because you have this measurement error in it. Now, the way we deal with that is we introduce some variability called treatment variability. If you want to try and identify what's causing one person to be happier than to another, that's when we do an experiment, and that's where we introduce treatment variability. And I'll talk about that next. So variability is created by a number of things, and as I said, measurement error, individual differences, and then both of those things just naturally occur. They're sort of outside of the control of the experimenter. You're always going to have measurement error, and things or people are almost always going to be different from each other on something. So you're always going to have those two sources of variability. However, if you set up an experiment, you could introduce some variability that is called treatment variability. So let's suppose that I have a group of people. This is a group of people. Each of these is a different person, and they differ in their amount of happiness. And then I have maybe a different another group of people. And of course, they differ. And what I'm going to do is I'm going to set up these two different groups of people, and I'm going to treat them differently. This group over here, I'm going to give them one level of a treatment. Let's say I'm going to make them take some boring class this semester, and then I'm going to measure their happiness at the end of the class. This other group, I'm going to give a different treatment. They're going to take statistics. It's going to be a fun, exciting class, and then we're going to measure their happiness at the end of the semester. Now, ideally, the two groups are about equal in happiness when we start the experiment. Of course, the people in the groups aren't exactly the same. There's individual differences, right? But hopefully, the groups are about the same when we start the experiment. Then they're going to go through the treatment. Some of them are going to take that boring class. Some of them are going to take that really exciting class. And then after the experiment is over, we're going to measure the two groups. Now, if one group has a lot more happiness than the other group, then we're going to conclude probably that whatever treatment they got created that higher level of happiness. The key point here is that treatment variability is created by the experimenter. It's something that they do by manipulating the type of treatment that participants get. As a summary point, measurement error, researchers try to minimize by using standardized procedures and the most accurate way of measuring whatever they're studying that they have available to them. Individual differences always occur, and researchers try to control them by starting experiments with groups that are about equal. They try and balance out individual differences. One group has just as much individual differences in it as the other group does. And then you have treatment, where one group is given maybe a control condition, a really boring class, and another group is given a stats class. And so their happiness, of course, goes through the roof. And so there's a lot more treatment variability here because this group has a lot more happiness than the other group. Hopefully that'll be enough to get you through Activity 2.2. And if you have any questions, give me a call.